In this video, we will practice finding limits like this one. First, let's go ahead and set it up. We are told that f of x is the square root of x. So this limit will become the following. The limit as x approaches 4. Now f of x is the square root of x. And then we have f at 4, so that would be the square root of 4. And the denominator remains x minus 4. Simplifying here, the square root of 4 is 2, so we get the limit as x approaches 4 of the square root of x minus 2 over x minus 4. You should always check and see if direct substitution will work. If we substitute 4 in for x in the numerator, the square root of 4 is 2, 2 minus 2 is 0. And then if you put 4 in the denominator, 4 minus 4 is 0. This is an indeterminate form which tells us nothing, so we need to use a different strategy. I see the radical here, so very often a good strategy to use is to multiply by the conjugate. The conjugate is the thing where if I have a plus b, then the conjugate will be a minus b. So here I have square root of x minus 2, so the conjugate would be the square root of x plus 2. And of course, we always have to multiply by the same thing in the denominator, so we're not really changing the value of the problem. The point of multiplying by the conjugate is that the result will always be a squared minus b squared. The middle part just automatically cancels out. So when you look at these, let me label it a little bit. So it doesn't matter which pair I look at, but this is my a and this is my b. So watch for the a squared minus b squared on the next step. So a squared, if I square this, I'm just going to get x. If you square a radical, the radical just goes away. So I need a squared minus b squared. And then b is 2, so b squared is 4. So multiplying these two just very quickly gives me x minus 4. I'm just going to keep the denominator the way it is. X minus 4 times the square root of x plus 2. All right, let's see what we have so far. You're probably noticing that we have this same factor of x minus 4 in the numerator and the denominator. This is very common, and we were hoping for something like this because we can cancel these out without changing the limit. So on the next step, we have the limit as x approaches 4 of 1 over the square root of x plus 2. At this point, direct substitution will no longer give us 0 over 0. So let's just use our direct sub and substitute 4 for x. So we get 1 over the square root of 4 plus 2. And of course, the square root of 4 is 2. And 2 plus 2 is 4. So I end up with 1/4. And that is the final answer. Number 19 still involves the square root of x for the function. So let's substitute that into the expression, and we will have the limit as h approaches 0. So f at 2 plus h means the square root of 2 plus h. All right, f at something just means you take that stuff and you plug it in. So that's what I did. And then f at 2 will be the square root of 2. And the denominator is simply the h. Again, if we were to do direct substitution, if we put 0 for h, then we just have the square root of 2 minus the square root of 2. That's 0. And if you let h be 0 in the denominator, that's 0 over 0. The indeterminate form tells us nothing. So we need a different strategy. I'm liking the strategy of multiplying by the conjugate again. That is probably my go-to strategy when I see that we have radicals. So the conjugate of the numerator will be the square root of 2 plus h plus radical 2. And I have to put the same thing in the denominator, the square root of 2 plus h plus radical 2. So remember, the benefit of multiplying by the conjugate is that you're going to end up with a squared minus b squared. This is a and this is b. So watch out for a squared minus b squared. So a squared, we're just going to take the radical away, and you're left with 2 plus h. So that's a squared. So I need a squared minus b squared. If I square this, again the radical goes away, so I just get this. So by multiplying by the conjugate, we really simplify this a bunch. The denominator looks a lot more complicated than it did a moment ago when we just had h, but you will quickly see that this expression has an advantage. And the advantage is right here. We get something that cancels out. So we can now write this as the limit as h approaches 0 of simply h over h times the square root of 2 plus h plus radical 2. And now that there is no addition or subtraction in the numerator, we can cancel these h's out, which is really what we needed to do so that we will be able to do the direct substitution that we want to do. So now we have the limit as h approaches 0 of 1 over the square root of 2 plus h plus the square root of 2. Now, direct substitution will not give us 0 over 0. So I'm just going to really show that. So I'm going to let h be 0 now. So I'm going to get 1 over the square root of 2 plus 0 plus the square root of 2. Notice how I'm really showing every step. We are preparing for the AP exam, and it's very important that the graders be able to follow your logic from step to step. So even writing down like, oh, this is 0, it pays to go ahead and show that instead of just skipping to the next step, so that the graders will be able to easily follow what you're doing and give you full credit on the AP exam. So these are like terms. So we have radical 2 plus radical 2 is 2 radical 2. And that is actually going to be the final answer. 1 over 2 radical 2. Let's just do a couple more. So f of x is 1 over x. If I want to do f at 3 plus h, that means I need to take my 3 plus h and plug it in right there. So this limit is going to become the limit as h approaches 0 of f at 3 plus h. So plugging 3 plus h in, I get 1 over 3 plus h. And then minus f at 3. So that means I'm going to take this 3 and plug it in. So that's just going to be 1 over 3. That's f at 3. And then in the denominator, we simply have h. I want to show you a quick side lesson so you can definitely follow what I'm about to do on the next step. I'm going to use 3 shortcuts. The first one is if I have a plus b over c, that's the same as a over c plus b over c. So you can kind of see that I've got that same situation here, right? I've got the difference of two things being divided by something, so I can split this up into 2 separate fractions. It's almost like the distributive property of division. Now here's something else, another shortcut that I like to use. If I have a fraction, like say a over b, and then I want to come along and divide it by something else. So say I want to divide this fraction by c. All you really do is put this thing that you're dividing by into the denominator. So a over b divided by c will be a over b times c. Whatever you're dividing by just joins into the denominator. So I'm going to do a combination of both of those things. So I'm going to take this h and I'm going to use it to divide both of these terms that are in the numerator. And like I just showed you, when you divide a fraction by something, it's going to join into the denominator. So watch for this h to show up here and here. So here's what you get. So I have the limit as h approaches 0 of 1 over 3 plus h. But now this h from the denominator, like I said, is now going to show up here. And then I have minus 1/3, but this h from the denominator, I told you it was going to end up in the denominator. So I have effectively divided both of these terms now by h. Okay, next I'm going to form like denominators so I can combine these into one big fraction. They both have an h, as you can see, but let's see, the denominator on the right has a 3 in the front. So the denominator on the left is going to need a 3 if it is going to match. And of course, you have to then do 3 over 3. You have to multiply the numerator by 3 as well. Now both denominators have 3h. But the first denominator also has a 3 plus h factor. So that means the other denominator is going to need a 3 plus h, and you really have to do 3 plus h over 3 plus h so that you're only multiplying by 1 and not changing the value of the problem. Now I have like denominators, so I can definitely go ahead and combine these. So I will now have the limit as h approaches 0 over my common denominator of 3h times 3 plus h. And then in the numerator, we have 3 minus 3 plus h. To be honest with you, normally I would skip this step and I would go straight to what I'm about to write next, which is the limit as h approaches 0 of, you can see that this negative sign is going to distribute throughout these parentheses. So I normally go straight to this, minus 3 minus h. But this is such a common mistake that a lot of students will just, they will not write the parentheses, and they will write 3 plus h right here without parentheses. So I really wanted to emphasize to you that we really have parentheses around the 3 plus h when you're subtracting that negative sign must be distributed, and this must become a minus h. So that is one of the most common mistakes that I see, so I just have to emphasize it. Okay, you probably can see what's going to happen next. When we combine like terms, we have the 3 minus 3, so those are gone. And we end up with the limit as h approaches 0 of negative h over 3h times 3 plus h. And I believe it is time for direct substitution. I'm going to let h equal 0. So we're going to end up with negative. No, I'm not going to let it. It's not time for direct substitution yet. If I did direct substitution right now, I would still get 0 over 0. It's time to realize that we have an h in the numerator and the denominator, and those will cancel out. And that will allow us to do direct substitution. I think I'll go ahead and show this right here. So we have the limit as h approaches 0. By the way, you have to keep writing the limit as h approaches 0 over and over again until you do your direct substitution at the end. So we have negative 1 over 3 times 3 plus h. Now we can do direct substitution. Letting h equal 0, we get negative 1 over 3 times 3 plus 0. And of course, that's just 3, so we have negative 1 over 9. By the way, if this was a free response question on the AP exam, they would also accept this for the answer. You know, once you do the direct substitution and the h is gone, you have a numerical answer and you're not required to simplify. So you can leave it like this. I am always going to simplify because what if it's a multiple choice question? This is what you would see, so I need to show you how to go all the way to a simplified answer. Here's the last problem. It will be a little bit different because there are more variables. So we are not going to get a numerical answer, we're going to get an expression. So f of x is 1 over x. F at x plus h means that we need to take x plus h and plug it in right there. So if we do that, we're going to end up with the limit as h approaches 0. Okay, f at x plus h. We're going to take this, but plug in x plus h right here. So we're going to get 1 over x plus h. And then minus f of x. So that means minus this right here. All over h. So this is going to go very quickly because it's so similar to what we did on the last problem. So I am going to take this h and I'm going to use it to divide both of these fractions separately. So watch for this h to show up in the denominator of each of these fractions on the next step. So I'm going to have the limit as h approaches 0 of, so here's my 1 over x plus h. But now I'm dividing by h, so I'm putting the h in the denominator. Similarly here, you see my 1 over x, but I'm dividing this by h, so it's going to end up right here. Now we can make like denominators. Both denominators have an h, but the denominator on the right also has an x to it. So I'm going to put an x. But I need to do x over x, so I'm not changing the value of the problem. The denominator on the left has x plus h, so the denominator on the right also needs an x plus h. But I need to do x plus h over x plus h, so I'm not really changing the value of the problem. I'm multiplying by 1. Now I have like denominators. So I think I will skip that step this time that I told you about on the last problem. This subtraction, please understand that this has to distribute, and it will change the positive h to a negative h. All right, please avoid that common mistake. So the limit as h approaches 0. All right, one big happy fraction. I have h. I think I'll put the x in the front. X times x plus h. So there's my common denominator. And in the numerator, I have x minus minus h. Again, I distributed the minus sign, so that's why I got the minus h. Notice we have the like terms right here. X minus x, they cancel out. So on the next line, these will be gone. So we have the limit as h approaches 0 of negative h over h x times x plus h. Alrighty then. These h's will cancel out. And we are left with the limit as h approaches 0 of negative 1 over x times x plus h. And now we can do direct substitution. Let's let h equal 0. So this expression will become negative 1 over x times x plus 0. So this is going to become negative 1 over x squared.